Hi, this is a pre-recorded class for Tuesday, May 26, 2020. Today we're talking about factoring polynomials, special cases. I need you to either have the Desmos app open or click on another tab for the Desmos graphing calculator. Okay, today we're going to talk about how to factor trinomials into binomials, which is actually a topic that we talked about last week. So today specifically we're talking about how to factor special cases, and we're going to also identify the parts of a quadratic function. Today's vocabulary words are x-intercept. Zeros and roots actually mean the same thing as the x-intercept. Today we're going to talk about perfect square trinomials and the difference of perfect squares. Okay, these are the laws of exponents rules. Okay, I would like you to factor this problem. X squared minus 4x minus 12. Please pause the video and do this on your paper. Okay, so to factor x squared minus 4x minus 12, we're looking for two numbers that multiply to negative 12 but add to negative 4. So those two numbers are negative 6 and 2. And for this reason, the factors are x minus 6 times x plus 2. So here it is in the area model. X minus 6 times x plus 2. X times x is x squared. X times negative 6 is negative 6x. 2 times x is 2x. And 2 times negative 6 is negative 12. So these two middle terms cancel out, and that's why it's x squared minus 4x minus 12. This is what a graph looks like for x squared minus 4x minus 12. So we make it equal to 0. So x is equal to 6 and x is equal to negative 2. So you can see those are the x-intercepts on the graph. Negative 2 and 6 are the x-intercepts. Now I would like you to pause the video and use distributive property for x plus 10 squared, which is x plus 10 times x plus 10. Okay, so x plus 10 squared would be x times x, which is x squared, x times 10, which is 10x, 10 times x, which is 10x, and 10 times 10 is 100. You'd add those two middle terms together, and you get x squared plus 20x plus 100. Now, what do you notice? You should notice that 100 is a perfect square. The square root of 100 is 10, and then 10 plus 10 is 20. So this is the sum of two of the perfect squares. Use FOIL. Okay, when you use FOIL, use distributive property. X times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. We add those two middle terms, and we get x squared minus 6x plus 9. What do you notice? You should have noticed that 9 is a perfect square. So the square root of 9 is 3. And negative 3 plus negative 3 is negative 6. So the square root of 9 is 3, but the square root of 9 is also negative 3. So since these are negative numbers, that's why it adds to a negative number. Now, let's work backwards. What is this 25 is a perfect square. So the square root of 25 is 5. 5 plus 5 is 10. So if we wanted to factor x squared plus 10x plus 25, we know that this is a perfect square and that its square root, two of the square roots add up to that middle term. So for that reason, it's x plus 5 times x plus 5, which is x plus 5 squared. These two are equivalent expressions. And if we graphed it, we would notice that there's only one in Desmos. We graphed it in Desmos. That's why I had you open Desmos so that you can put this in the graph. If we graphed it, there's only one x-intercept, and that's at -5. Okay, I would like you to factor these. Pause the video and factor it. Okay, since 144 is a perfect square, you can take the square root, which is 12, and 12 plus 12 is 24. 64 is a perfect square. The square root of 64 is 8 or -8. So -8 plus -8 is equal to -16. So those are the factors. If we graphed it, we would notice that it only has one x-intercept, and that's at +8. I would like you to pause the video and use distributive property. Okay, when you use distributive property, notice those two middle terms cancel out. So those two middle terms form a zero pair. And since they're a zero pair, it's called the difference of squares, of perfect squares. So you can see that if it looks like this, then you can factor it as a difference of perfect squares, where it's the same number, but one is positive and one is negative. So factor this. Pause the video. So the square root of 64 is 8, so it's x plus 8 times x minus 8. Pause the video and factor all three of these, please. So the first one is the difference of squares, so it's x plus 7 times x minus 7. Difference of perfect squares, x plus 10 times x minus 10. And this one is a perfect square trinomial. So it's the square root of 49 is 7, and 7 plus 7 is 14, so it's x plus 7 squared. If we were going to graph these, you would notice this one, that's the difference of squares, has two x-intercepts at 7 and -7. But this one, which is a perfect square trinomial, it has one x-intercept, and that's at -7. Please pause the video and write down the x-intercepts of these graphs. So the x-intercept for this first one, since it's a perfect square trinomial, is at -3. It has one x-intercept, and this one has two x-intercepts at 2 and -2. Notice this point is the y-intercept. We're talking about the x-intercept where it crosses the x-axis. See you next week. You need to do both assignments. It's an extra long quiz is, so it's a double assignment. Thank you. See you next week. Next week is the last lesson. Bye.